Welcome to the Explainer. Today, we're going to pull back the curtain on one of the coolest pieces of tech that, honestly, keeps your digital life running smoothly, the Kubernetes ReplicaSet. So let's just start with a really basic question. You use, what, dozens of apps every single day, right? And most of the time, they just work. But what you don't see is that behind the scenes, things are failing constantly. So what's the secret? What's this invisible force that's holding everything together? Well, to get it, you have to understand this massive shift in how we think about technology. In the old days, we treated our servers like pets. You'd give them a special name, you'd nurture them, and if one got sick, you'd spend hours trying to fix it. Not anymore. Today, in the world of Kubernetes, we treat our applications like cattle. They're totally interchangeable, and if one has a problem, you don't fix it, you just replace it. And you need this cattle approach because the basic building blocks in Kubernetes, these things called pods, they're incredibly fragile. They are designed to fail. The code inside can crash, it can run out of memory, the whole server it's on could just die, or heck, someone could even delete one by accident. The key thing to remember is that a pod is temporary. It's disposable. Okay, so if every single one of these pods is built to be so fragile, what stops the whole system from just, falling apart? The answer is this amazing automated guardian. It's a core part of Kubernetes, and it's called the ReplicaSet. Probably the absolute best way to understand a replica set is to just think about the thermostat in your house. It does a really simple three-step job, right? First, you set a desired temperature, let's say 22 degrees. Then it's constantly checking the actual temperature. And if there's a gap between what you want and what it is, it takes action. If it's too cold, it just turns on the heater. Simple. A replica set works the exact same way, but it does it for your app's pods. You tell it what you want, you declare your desired state. Hey, I always want 3 identical copies of my app running. The replica set is constantly counting the actual state. I only see 2 healthy pods right now. And then it acts to fix the difference by creating a new one. That's it. That is its entire mission in life. This constant cycle, observe, compare, act, over and over again, is an incredibly powerful idea in automation called a reconciliation loop. And it's really the engine that makes Kubernetes tick. What's so cool is that it doesn't care why a pod is missing. It just sees that the current reality doesn't match what you want, and it fixes it. This makes the whole system unbelievably resilient. So, how does the replica set actually pull off this little magic trick? Well, it uses 2 really simple but very powerful tools. First, it has what you can think of as a cookie cutter. It's a pod template that spells out exactly what a brand new pod should look like. And second, it has glue. This is called a label selector. It's how it scans the entire cluster with maybe thousands of pods and figures out exactly which ones belong to it. And we're not talking about simple craft glue here. This selector is really sophisticated. It uses set-based logic, so you can make some pretty complex rules. For instance, you could tell it to manage all pods that are in production or staging, but, and this is key, to specifically not touch any pods that are marked for debugging. It gives you this incredible level of control. All right, theory is great, but let's see how this all comes together in the real world. We're going to walk through a typical failure scenario and just watch the replica set do its thing. Okay, so here's our application. The replica set is configured with a desired state of 3 pods. As you can see, right now, everything is humming along perfectly. And then, boom, disaster strikes. One of the actual physical servers, what we call a node, that was hosting 2 of our pods just goes completely offline. Total hardware failure. And just like that, 2/3 of our app's capacity is just gone. The actual number of healthy pods plummets from 3 down to 1. But here's the magic. Before a human engineer even gets the alert on their phone, the replica set's reconciliation loop kicks in. It sees the mismatch. Desired is 3, actual is 1. That's a deficit of 2, so it immediately gets to work. And there you have it. This shows the self-healing power of the system perfectly. The replica set uses its cookie-cutter template to create 2 brand new pods, and Kubernetes finds healthy servers to put them on. The desired state is restored, all automatically, usually in just a matter of seconds. So we know that replica sets are absolute masters of keeping things stable. But what happens when you want to introduce change? Like, say, updating your application to a new version. Yeah, here's the catch. A replica set by itself is actually pretty terrible at managing change. Its whole job is to prevent it. This is where a higher level tool comes in, the deployment. You see, you almost never manage a replica set directly. Instead, you talk to the deployment, and it acts like an orchestrator managing the replica sets for you. So when you tell the deployment, hey, let's update, it does something really clever. It doesn't mess with the old replica set. Instead, it creates a brand new one for the new version, but it starts with its desired count set to 0. Then, the deployment performs what people sometimes call the dance of the replica sets. It very carefully scales up the new set one pod at a time, while at the exact same time scaling down the old one. This rolling update strategy is what ensures your app is always available, even during an update, 0 downtime. Okay, let's zoom out for a second. Why is this whole self-healing automated architecture so important? Why does it matter so much? This quote just captures the whole shift in thinking perfectly. We've gone from a world where an engineer gets paged at 3 a.m. to go fix a broken server, to a world where the system itself fixes the problem before a human even knows it happened. It's a move from being reactive to being proactive. So, let's wrap this up. What are the big ideas you should walk away with? First, pods are disposable cattle, not precious pets. Second, replica sets are the thermostats that make sure you have the right number running, which enables that amazing self-healing. And finally, deployments are the conductors of the orchestra, using replica sets to roll out changes safely. You know, this revolution in automated reliability, it's not just some nerdy technical detail. It is the fundamental building block of the always-on digital world that we all depend on for, well, everything. And that kind of leaves us with a final, pretty exciting thought. If our applications can now heal themselves from failure, what does that free us up to build next?